So today is the last type of word problems that you're going to learn before you take your test on Friday. So I'm sorry that I'm not there, but hopefully these notes help you at least get started, and then we can look at them again on Wednesday. So we're going to talk about direct and inverse variation. So the first type is direct variation, and it says it is one special type of linear function. So a linear function is just like a graph that makes a straight line. And a situation that translates to an equation of this special form, where k is a non-zero constant, is direct variation. So this is what you need to know for direct variation. Y equals kx. And when we read something, it's going to say y varies directly, so that's your key, varies directly as x. Now these letters go together in the correct order. So like when you see this y, that's what comes first. And when you see this x, that's going to come second with the k. So you won't always see y and x because you're going to see things like, on your examples, like dollar amount and time. You'll see things like perimeter and side lengths. Okay, so you won't always see y and x, but whatever goes first that says like dollar amount varies directly as the number of hours, then you know which one represents y and which one represents x. So it says if k is positive, the value of y increases as the value of x increases. Okay, so direct variation, both of the things that you're talking about are going to be increasing. So on number 1, it says the dollar amount that Julia earns varies directly as the number of hours that she works. So for direct variation, if it says varies directly, our dollar amount is going to increase as our time increases. Okay, so that's what this part says up here. The value of y, which in this case is our D, our dollar amount, varies directly as the number of hours. So the dollar amount increases as the value of x, or in this case our time, increases. So it says D equals 116.25. So under D, to make this easy, let's write 116.25 or $116.25. So when D is 116.25, T is 15 hours. So it's almost like a little chart here. You have your dollar amount and your time. You have your given. So when she gets $116.25 when she works 15 hours. So then it says find T. So we don't know what T is. I'm going to put a question mark. When D is $178.25. Okay, so you have a little bit of information here and you need to find the missing part. So what we're going to do is we're going to use that equation, y equals k times x. But instead of the y and the k, let's input our d and our t. So this becomes d equals k times t. So k is just called the constant of variation. So in a situation like this, it just doesn't change. The k will always stay the same no matter what the d and the t are. So let's input our d and our t that we know. So we know that she makes $116.25 when she works 15 hours. Okay, so I'm inputting the two givens, the two things that we know. And I want to solve for k. So I'm going to divide by 15 on both sides. And when I divide, I find out that k equals 7.75. Okay, so we put in the original dollar amount and time to find k. So now this is kind of a two-step process. I want to take the k that I found in this same equation and I want to find t. So again, I'm going to write the equation we're using, d equals k times t. Now on this part, I know the dollar amount is $178.25 equals, now last time we didn't know k, but this time I know k is 7.75, and I want to find what t is. So I'm going to leave t as just t, and we want to find out, well, what does t equal? So to find t, I'm going to divide by 7.75. And when you divide, you should get t equals 23 hours. Okay, so you set up your equation or this little chart here, you write your two givens, and then they say, well, now find t when the dollar amount is this. So the first thing you do is you put in those two numbers that you know, and you solve for k. Then we take that k with the one piece of information they gave us, and we solve for the missing part. Okay, so let's do the same thing on number 2. It says the perimeter P, perimeter P of a regular dodecagon varies directly, so there's your key to know which equation you're using. So we're going to use y equals k times x. So we have the perimeter P, so as P increases, the side lengths increase. It says P equals 18 when S equals 1.5. Find S, so we want to put a question mark where S is, when P is 75. Okay, so now instead of the y and the k, again, input what you have here. So we have P equals k times S. So we want to find the k. So we're going to put in this first row. 18 equals k times 1.5. So go ahead and solve for k. So you should have divided by 1.5. You find out k equals 12. So now that we know 12, we're going to do this same process we did here. So I have P equals k times S. So we want to plug in what we know. Well, now we know P is 75. We don't know S, but we just found what k is. So I'm going to put 12 in for k times S. And we're going to divide by 12. So S equals 6.25. So that's direct variation. One increases, the other increases. You use this equation, y equals kx, input the variables that you're using, like perimeter inside or dollar amount in time, and find the k. And then use that k to find the missing variable. So let's look at now inverse variation. So inverse variation, here's the little saying, y varies inversely. So instead of directly, you're going to see inversely. And then this is the equation we're going to use, y equals k divided by x. And it says in this situation, one quality increases and the other decreases. So think of inverse. One goes up, the other goes down, whereas directly, they both go up. Okay, so nothing has changed though from what we just did. Everything's going to be the same. We're just going to use a different equation. So number 1 says if y varies inversely as x, so y goes up, x goes down. Still going to make that same little chart that we made up above. And the equation we're going to use is y equals k divided by x. It says y equals 4 when x is 12. So we'll put 4 in for y, 12 in for x. Find y when x equals 5. So we're going to find y when x equals 5. So let's plug in what we do know. We know the 4 and the 12, so y equals 12. We don't know k, and y equals 4. Y equals 4, and x equals 12. So to solve for K, we're going to multiply both sides by 12. So K equals 48. Then we're going to take that K and use it to find what the Y equals. So we have the same equation, Y equals K over X. So now here we don't know what Y is, so we're going to leave that as Y. But now we just found that K was 48 over X is 5. And if you divide that, you should get Y is 9.6. Okay, number 2. The time T that it takes for a group of volunteers to construct a house. So we're talking about time. It says varies inversely as the number of volunteers. Okay, so our equation, Y equals K over X. Instead of Y, we're going to have time. And instead of X, we're going to have V for volunteers. So as time goes up, the number of volunteers goes down. So it says if 20 volunteers can build a house, so 20 volunteers can build a house in 62.5 working hours, how many volunteers would be needed? So we need to find how many volunteers would be needed to build a house in 50 working hours. Okay, so let's start with this first column right here, or first row right here. So we have 62.5 is equal to K over 20. So we want to multiply both sides by 20. And we find out K is 1,250. So now we want to use that K in with this 50 so we can find how many volunteers it takes in 50 hours. So we have T equals K over V. So we're trying to find V. So we have T is 50 equals K, which is 1,250 over V. So in order to solve for V, we want to get it out of the denominator. So I'm going to multiply it first. So I have 50V equals 1,250. Divide by 50. So V equals 25 volunteers. Okay, so we're going to go down to this part right here, and we're going to do this combined variation on Wednesday. But let's look at this part here. It says determine whether each represent direct or inverse variation. So remember, direct is like the same direction. If one goes up, the other goes up. Whereas inverse, one goes up, one goes down. So on number 1, it says the number of pancakes made and the amount of mix used. So if you're making pancakes and you make more pancakes, so the number of pancakes increases, ask yourself, well, does the amount of pancake mix used increase or decrease? Well, if you're making more pancakes, you need more mix, so that's increasing. And since they're going the same direction, that would be an example of direct variation. So you have the number of pancakes and the amount of mix. Number 2, the price of milk and the number of gallons you can buy for $20. So let's say the price of milk goes up, which it always does. The price of milk goes up and the number of gallons. So if the price of milk goes up, can you buy more gallons or less gallons for $20? Well, you're going to end up buying less gallons, so you don't get as much bang for your buck. So as the price of milk goes up and the number of gallons goes down, that would be an example of inverse variation. Number 3, the outside temperature in winter and the amount of fuel required to heat a house. So you have outside temperature and amount of fuel required. So let's say the outside temperature goes up. Let's say it gets warmer out. Is the amount of fuel required, do you need more heat or do you need less heat? You need less heat. So since they're opposite, that is inverse variation. Number 4, a child's age and his height. We have age and height. So as a child gets older, their age increases. Does their height increase? Yes, it does. So that would be an example of direct variation. And number 5, the number of apples purchased and the total cost. So if you buy more apples, does your cost keep going up or does it go down? I guess it depends if there's a sale or not. But number 5 would be direct variation as well, since they're both going the same way. Okay, so we're going to do these two combined variation problems on Wednesday because they're a little bit tricky. It's kind of a combination of your direct and your inverse variation. So the substitute will tell you which problems on your homework to have done or have at least tried for Wednesday.